Hi, this is Mrs. Cribb, and this is the video lecture on Chapter 3A, which is the very beginning of Chapter 3. I'm going to be going back and forth between the Prezi and the notes again. So here, at the very beginning of the Prezi, is the Quizlet, of course, and you can click on the Quizlet, and it takes you to the Chapter 3 Quizlet with its terms. There are 43 terms. This chapter has a lot more math in it, but notice how it has the prefixes and things you can remember about it, like kilo means 1,000, or it's 10 to the third power, and pictures to remind you. So again, you can go straight to the Quizlet from the Prezi, and then we're going to go from there to the next slide. Chapter 3 notes on measurement. Measurement is the act of comparing an unknown quantity to a standard unit, and it consists of a number and a unit. And a unit actually means, uni means one, so the unit means one of something. A dimension is a measurable quantity, so like length and volume and time and charge. And so we're going to look at something. If I wanted to pretend that the height of this girl student here was called a toddle, that would be my unit. One girl here is a toddle long, and then maybe I could take that and measure how long the classroom is, like how many toddles or how many girl lengths the classroom is. So the unit in that case would be a toddle, but we all have to agree that this girl is one toddle in height, and then everybody else would be kind of compared to that. All right, so that brings us to calibrating. So this says explain and draw how to calibrate a Celsius thermometer. So this is just a visual of how to do that. So what you do is you take your tube with some of your liquid in it, and you put it in freezing water, ice water, and you mark on that tube where that liquid is, and that's going to be, you're going to consider that your zero. That will be your first fiducial point. And then you take that same tube and you put it in boiling water. Now you wouldn't take it straight from the freezing water to the boiling water because it might break because of the glass and something called thermal expansion. But the liquid would heat up, and as things heat up, they expand, so it's going to force the liquid to go up the tube. And when it stops going up, you mark that as your next fiducial point, your 100. And then you just divide that area into 100 equal spaces to be 100 degrees Celsius. And that's how you calibrate a thermometer. The markings are the subdivisions or the lines, and this is a graduation, a graduated thermometer. So you put it in freezing water, mark it. You put it in boiling water, mark it. Then you divide it into 100 spaces, evenly spaced spaces, to make the Celsius thermometer. Okay, we're going to be dealing with the metric system, which is based on units of 10. The modern metric system, called the SI metric system, was adopted in 1960, and you don't have to know when it was adopted. These are the quantities that we're going to be measuring. Now, I have marked out in blue the ones you don't need to know yet. We're just going to deal with length, mass, time, and thermodynamic temperature, or just temperature. We're going to be dealing with kelvins. And of course, in Chapter 2, we dealt with Fahrenheit and Celsius as well. But these are the SI units: meter, kilogram, second, and Kelvin. And I will take, instead of kilogram, I will also take gram, and you'll understand why in a few minutes. The symbol for meter is a little m. The symbol for kilogram is kg, because kilo means 1,000, kilogram means 1,000 grams. Second is an S, and Kelvin is a K. These are what you have to know now. We will learn the mole second semester, and we will learn it until you're sick of it. From these base units, you can derive or come up mathematically with other units. So we talked a little bit about that, the fact that the joule is the unit for energy in our last chapter. And you can notice here that a joule is equal to 1 kilogram times meters squared divided by seconds squared. So all of this is called deriving this one unit. So rather than having to write all this stuff every single time, we just say 1 joule. And we just know that one of these joules is actually all these base units, these units here, these base units are included in this unit, the joule. Now you don't have to memorize this. This is just an example of showing you how other units can be derived from the base units. Now this is where it starts to get important, and I've marked in the Prezi from giga to nano. That blue line shows you the ones that you need to memorize. So from giga to nano. And I'm going to go back at this point and look at your actual notes. I don't need to explain this anymore. It's already in the Prezi. Let's go down here. Again, I marked out the ones you don't need to know. So from giga to nano. So mark this in your notes as well. So let's see here. I'll use a big old blue. Giga, mega, kilo, all the way down to nano. That's the units where you're going to have to know the prefixes. You have to know these prefixes, the ones that I've marked, all the way down. And you got to know what they mean. Now you also need to know the symbol. Giga is a big capital G. Mega is a big M. And then kilo is a small K. Hecto, which means 100, is an H. Deca is a D-A. Deca means 10. It just means 10. Deci is also a D, and it means 1/10. Notice that deci is just the little d. And then centi is a C, milli is an M. Micro is this funny looking symbol. If I make my pen a little bit smaller, it just kind of goes like this, micro. Okay, you gotta get used to that, micro. Nano, N, and then not going to worry about the rest of them. Right, but you do have to know these. So what else can we pay attention to here? Giga is a billion. And you may have heard of gigabytes. That's a billion bytes of information. And a billion, here's the number of billion. Notice how it has 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So a billion is 10 to the 9th power. It's a 1 with 9 zeros after it. So a gigameter means a billion meters. And we have 9 zeros after the 1. Mega million, mega million, mega million. Say that, okay? Mega million. Capital M. All right, million has 6 zeros in it, so it's 10 to the 6th power. Mega million means 1 million meters, or mega meter means 1 million meters. Kilo, which means 1,000. So a kilometer means 1,000. It has 3 zeros after it, so it's 10 to the 3rd power. Hecto means 100. There are 2 zeros in it, so it's 10 to the 2 power. Deca is 10, so it's 10 to the 1 power. It has 1 zero after it. And this is right here would be the base unit. And the base unit has no prefix on it. All right, the base unit has no prefix. Look, it has a number 1 with no zeros. So it's 10 to the 0 power because any number to the 0 power is equal to a 1. Deci is 1/10. So see 0.1, that's 1/10. And so that's 10 to the minus 1 power. So it's a 10th. Centi is 100th, or 1 to 100, 10 to the negative 2 power. Milli is 1,000th, 1 to the 1,000 power, so 10 to the minus 3. Nano is a billionth. I skipped micro. Micro is a millionth. It's a point and then 1, 2, 3, 4, 5, 6 spots. So it's 10 to the minus 6. And I'm going to show you a mnemonic device for these. And then nano is a billionth. So 10 to the minus 9. Nano 9. That's how I remember that. Nano 9. I know it's 10 to the minus 9. Mega million. Mega million. So I can remember that a megabyte or a megameter or a megagram is a million grams. All right, now we're going to memorize giga, mega, kilo, hecto, deca, deci, centi, micro, milli, micro, and nano. And we're going to use this mnemonic device, and y'all are just going to have to bear with me. It goes like this, and it goes giga space space, mega space space, King Henry drank Ucky dark chocolate milk. Space space, micro, space space, nano. Say it again. Giga space space, mega space space, King Henry drank Ucky dark chocolate milk. Space space, micro, space space, nano. Again. Giga space space, mega space space, King Henry drank Ucky dark chocolate milk. Space space, micro, space space, nano. Now, remember that Ucky is for the base unit. And so that's the base unit. And it's 10 to the 0. And so then we're going to go, when we go this way, we're going to have positive, and when we go to the left, we're going to have negative. So this is 10 to the 0. And this is 10 to the 1, or just 10. 10 to the 2. I wrote 100, sorry. I'm thinking ahead. It's 10 to the 2, so it's 100. I'm going to write smaller too. 10 to the 2, so this is 100. And 10 to the 3, so sorry, we're negative. These are negatives. Negative 1, negative 2, negative 3. Milli. So that's 1,000. So this is deci, 1/10, centi, 1/100th, a milli, 1,000th. Sorry. It's getting smaller when you go to the right. It actually gets a smaller unit according to this mnemonic device, and then bigger on this side, which is kind of opposite of what you see on the timeline. And I apologize, I didn't say that right correctly the first time, rather. So uki is for unit, dark is for deci, chocolate is for centi, milli is milk is for milli, and then space. So that would be a -3, so this would be a -4, a -5. So micro would be a -6. And that's why I put the spaces there, -5. Micro is that weird little symbol, and then this would be a -7, 10 to the -7, -8. So nano is a 10 to the -9. All right, now micro is also 1/1,000,000th, and nano is 1/1000,000th. 1 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So, gigaspace, megaspace, King Henry drank Ucky dark chocolate milk. Space, micro, space, nano. For giga is a billionth, a billion, 1 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the +9. And then that would be +8, 10 to the +7. Mega is a million, 1, 2, 3, 4, 5, 6, or 10 to the 6th. And then 10 to the 5th, 10 to the 4th. So you see it's the exponents that are larger on this side, and they get smaller on the other side. And then king is for kilo, and these are going to be the main ones you have to know, and that's 1,000, or 10 to the 2. 10 to the 3, because that's 10 to the 4. H is for hecto. D, and so that's 10 to the 2, which is 100. D is for deca. I gotta make sure I spell that right. I'm always like, okay, DECA. Told you all I'm bad at this. It's 10, and then that's the unit. So let's say them again. Gigaspace, megaspace, King Henry drank Ucky dark chocolate milk. Space, micro, space, nano. The most important ones to remember are these guys right here. But we will be dealing sometimes with the ones on the outskirts, micro possibly. But it's good to know the relationship. The giga is a billion, and it's the biggest one. Nano is a billionth. It's the smallest one. A nanometer is a billionth of a meter. It's super small. Now, other things that you need to know are that 60 minutes is an hour, 60 seconds is a minute, 1,000 meters is a kilometer, a kilometer, because kilo, the K that means 1,000. So 1,000 meters actually means 1,000. The K gets turned into 1,000 meters. The M turns into meters. So 1,000 meters would be 1 kilometer. The K, it means 1,000 meters. Just like 1,000 milliliters would be 1 liter. Milli means 1,000th. So a milli means 1,000th. So if I have 1,000, right here, there's a number, times milli, which is 1 over 1,000. Notice how it cancels out, and I get 1. So millimeter, 1,000 milliliters equals 1 liter. And you better get this, okay, guys, because I have a liter beaker back there, or at least a 500 ml beaker, and I can make you put one little drop in there at a time, 1 milliliter at a time, until you get 500 of them or 1,000 of them to make your liter or your half a liter. So these are metric units that you should know, and you should know them by heart. And I'm not going to put these on a reference chart. I'm not going to put these prefixes on a reference chart. You must know them. Gigaspace space, megaspace space. King Henry drank a key dark chocolate milk. Space, space, micro, space, space, nano. That's all of them. Now, a unit conversion is just the process you're going to do something with. Consists of multiplying a measurement by a conversion factor. And so this right here, the unit conversion, is the process you're going to do. I'm going to do a unit conversion. I'm going to convert one unit into a different unit. And then a conversion factor is just a tool that you use to make this happen. So here's some conversion factors. There are 1,000 milliliters over 1 liter. What is 1,000 milliliters? Well, up here I told you 1,000 milliliters. Right here, let's look at this one. There's a relationship. 1,000 milliliters equals 1 liter. So I could take this 1,000 milliliters on top and put something that's equal to 1 liter. Now you see, it's exactly the same on the top and the bottom. These things are the same distance. So same thing here. 1 liter is 1,000 milliliters. I could change 1 liter. There's a relationship. Since they're equal to each other, I can substitute it in. I'm going to substitute 1,000 milliliters. You can see top and bottom are identical. So what are these all equal to then? 1 liter over 1 liter equals what? 1. So a unit conversion takes something that's equal to 1 to change it from one thing to another thing. So this is equal to 1. So 1,000 grams means a kilogram, because 1,000 means a kilogram. And there's the G. They're identical. You could also flip it upside down. 1 kilogram to 1,000 grams. 60 minutes is 1 hour. So I could cross that out and put what it's equal to. 60 minutes is equal to 1 hour. Now you see the top and the bottom are the same. 1 hour is 60 minutes. 60 seconds is 1 minute. I could put 60 seconds on the bottom. So you're going to use these relationships to change your units from one thing to another. So I'm going to convert some with you right here. And we're going to use something called bridge notation. And this is going to be super important. Now you can use the gigaspace space, megaspace space, King Henry drank a dark chocolate milk to help you when you're just going from metric to metric. But when you're going from metric to English, it's not going to work. But bridge notation is much more important for you to get down, and you must do it like I'm doing it. So we're going to convert these number of centimeters to kilometers. That means kilometers is the unit I want to end with. Whenever you do that, you write down what you have. I have this many centimeters. Okay, and I'm going to make something that's going to look like the beginning of a bridge. Now it's called bridge notation because sometimes you're going to start and you're going to have math and you're going to have more math, you're going to have more math until you get an answer. And it looks like a bridge. You know, you're walking across the bridge to get to the final answer. Okay? But this one is that first one is just one step. So I want kilometers to be my answer. So kilometers, km, needs to be the unit on top. And I need to cancel out the centimeters right here. So centimeters has to be on the bottom, because you can think of this also as just a multiplication factor. You could write it like 132,540 centimeters over 1 times. All right, what is 1 kilometer over how many centimeters are in a kilometer? Okay, now centimeters means 100. Okay, so it takes 100 centimeters for 1 meter. Okay, so I'm not going to go directly to a kilometer in this case. I'm actually going to need to make this more of a two-step process. And so I started off writing it like that. Then I realized, okay, wait a minute, I can't go. So here is, let's see, we got centimeters. We're over here at centimeters, centi. This is the centi. I need to get to kilometers. So notice that I need to go through the unit, the base unit. Okay, what is the base unit for length? So if you go back up when we were talking about that here, the base unit for length is a meter, the M. So I'm going to go through the base unit, and then I'm going to convert from the base unit to the final unit. So this really is going to be a two-step process, not just a one-step. So I'm going to have to actually go to meters on the top first and centimeters on the bottom. So it will look more like a bridge by the time I'm done. Now, what's the relationship between meters and centimeters? Centi means 1/100th. Just like a cent is 1/100th of a dollar. It takes 100 cents to make $1. So since a centimeter, which is only about this big, it takes 100 of those to make a meter. And you can look at a meter stick and see that. So it takes 100 centimeters to make a meter, to make 1 meter. So that's a relationship. Please get this down. 100 centimeters equals 1 meter. You must know that. You may look at a meter stick and see that, and maybe I'll pull up a picture of one and put it in the Prezi and make sure it's there later on. All right, so now once I do that, this is just a numerator and that's a denominator. Remember, they can think of this as a multiplication. If it's on top, you're multiplying by something. If it's on the bottom, you're going to divide it. So this is a numerator and a denominator. They cancel out so that my new unit, and notice too, the numerator here should cancel on the bottom somewhere. Now I have my answer would be in meters. If I did my math, I'd say 132,540 divided by 100. Because if it's on the bottom, you're going to divide by it. Okay, if it's on the top, you're multiplying by it. All right, now I've changed it into meters. Now I'm going to change my meters into kilometers. So now this unit's on the top, so it needs to go on the bottom on the next step. And kilometers needs to go on the top. And remember this relationship. 1,000 meters is equal to 1 kilometer. This is the relationship I'm using. And I can put either one of these guys on top, meters or kilometers. Well, I need kilometer to be the final unit. So kilometer goes on top, meter goes on bottom. So now I'm going to cancel out the meter on the numerator and the meter in the denominator. And it's 1,000 down here. Sorry, that's right. 1,000 meters is 1 kilometer. See that? 1,000 meters is 1 kilometer. So now I can put it into my calculator and pull it up and do the math. We have 132,540, and I'm going to divide it by 100 right here because it's below the line, so I'm dividing by 100. And then I go to the next spot, and I'm going to see that's still a division sign right here. So since it's still saying division, still says division, I'm going to divide again by 1,000. So pull it back up. So I divided by 100. I'm going to divide again by 1,000. And that gives me my answer of 1.3254. So 1.3254 kilometers. And that would be my answer. 1.3254. So let's try this next one. All right, we're starting with 350 milligrams. And we're going to go back up here. I'm going to erase my lines for a moment. So, hold on. Okay, so I've gone up here and I've cleaned it up a little bit. We're going from milligrams to kilograms. So, let's find it up here. Milli is this M. So, we're going to go from milligrams to kilograms. And we're going to have to go through the base unit. So there's a two-step process again. We're going to go from milli to base unit, from base unit to keme, which is kilo. A lot of times you're going to have to go through the base unit. And so that means it's a two-step process. So I have to go then from milligrams to what's the base unit for mass? Grams. So the base unit for all these base units up here. And that's why I said I would take, instead of kilogram, I will take grams, because that's the one in the middle with no prefix. The base units here with no prefixes. Okay, meter, gram, second. Another base unit for volume is not listed up here. Length for volume it would be liter. Okay, and just notice that that one's not up here. Okay, so from milli to the base unit, what's the relationship? Well, milli means 1,000th. So it takes 1,000 of them, 1,000 milligrams is going to equal 1 gram. Because it's only 1,000th of a whole, it takes 1,000 of them to equal the base unit of 1 gram. So gram has to go on top, milligram has to go on bottom, because I have to be able to cancel it out. And it takes 1,000 milligrams to 1 gram. See this? There's the 1,000th right there, 1,000th. Now we can cancel out the units. We have the numerator and the denominator, and we cancel, cancel. And if I stop my math right now, I just say 350, and this is where you look and see it's below the line, so I divide it by 1,000. But that only gets me to grams, and I have to go to kilograms. So I have to add more. So now I've got to get rid of the grams. So the gram unit has to go on the bottom. So whatever was on the top of this part needs to probably be at the bottom on the next part. And then kilograms goes on the top. So now we look up here. We just went to grams, but we got to get to kilograms right there. So that's the next step. So what's the relationship between grams and kilograms? Well, it's the same thing as between meters and kilometers. There are 1,000 grams is 1 kilogram. So 1,000 grams is 1 kilogram. See how I have this relationship, and I could put either one of them on top. The one that goes on top is the one I need to finish with. So now I'm going to circle my grams because it's in the numerator, and my grams because it's the denominator. I just do this as I'm teaching it to help you to see it has to be canceled out. Grams and grams have to cancel, otherwise you're not going to get the answer. Now, multiply through to get your final answer. So this time, it's 350 divided by 1,000, and see right there, and you can divide again by the second 1,000. Divide by 1,000. Do it exactly like I said. Go from step here to this part, I'm going to divide by 1,000. Then to this part, I'm going to divide by 1,000 again. And then hit enter for your answer, which is 3.5 e minus 4. That e means the exponent of your number 10 is a negative 4. So it's 3.5 e negative 4, but we're not going to write it that way. We have to fix it into normal convention. It's 3.5 times 10 to the negative 4. See that? E is the exponent of a negative 4. So it's 3.5 times 10 to the negative 4 kilograms. E negative 4 is not an acceptable answer. You must write it in normal convention. Okay? Let's try nanometers to meters. So I'm going to clean it up again for you, and then we'll do that. All right, I cleaned up the top again. So we're going from nanometers to meters this time. Let's double check that right. Nanometers to meters. NM, nanometers. So let's find nanometers. Here it is. We have to go from nanometers through the base unit, then to, well, it looks like that's all we got to do, nanometers to meters, because meters is a base unit. It has no prefixes. Remember, the base unit has no prefix. Okay, nano means 1 billionth. 1 billionth. There it is again. Nano, and it means 1 billionth. So it takes a billion of them to equal the other thing. And then you could say that a meter is 10 to the minus 9 nanometers. See this relationship? You could say 1 meter equals 10 to the minus 9 nanometers. Sorry, that's wrong. 10 to the minus 9 meters equals 1 nanometer. And that's why I don't like to use it. For some reason, I just kind of get backwards with that. I like to think in whole numbers for this. So it takes a billion nanometers to make 1 meter. A billionth. A nanometer is so tiny, it takes 1 billion of them to make a meter. Okay? So I'm going to write that relationship here. There are 1 billion, or nano 9 zeros, 1 billion nanometers equals 1 meter. That's how I like to remember it. Okay? So let's change this. 670.7 nanometers. And we're going to change it to meters. Meters is the base unit, has no prefix. So 1 meter is 1 billion nanometers. So then see, I use this relationship. I put meter on the top because I need to get that answer in meters. I'm going to cancel out nanometer and nanometer. And so take 670.7 divided by 1 billion. So let's turn on the calculator again. And I'm going to clear it. 670.7 divided by 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nano 9. Enter. 6.707 times 10 to the minus 7. That E is the exponent again. 6.707 exponent negative 7. So 6.707 times 10 to the minus 7 meters. And like I said on your calculator, if you look at it, it says E, but that is not how you write it. You write 10 to the minus 7. It's the exponent. All right, let's do one more. We're going to change a megagram to a milligram. So I'm going to go back up here. Let's find mega. Here is mega right here. Mega million, mega million. So mega means 1 million grams. So megagram is 1 million grams. 1 megagram, capital M, is 1 million grams. Megagram. Mega million, it's really big. So there's a relationship. 1 million grams. So there's 1 million grams is 1 megagram. So I'm going to go this time from a megagram to the base unit, which has, and then from there to milli, because I think it does ask you to go down to milligram. So this is a two-step process. Go through the base unit. So first let's convert 0.0043 megagrams. First I'm going to convert to the base unit of grams. So 1 million grams, 1, 2, 3, 4, 5, 6. 1 million grams is 1 megagram. See, relationship right here. Cancel out the megagram here and here. And that means if I stopped my math, I would have, the unit would be grams. But I need to get down to milligrams. So was a milli means 1,000th. 1,000th. So 1,000 milligrams is 1 gram. This is super small, a milligram. It's even smaller than the paperclip size, which is only 1 gram. So 1,000 milligrams is 1 gram. And that's what I need. I need milligrams. So 1,000 milligrams is 1 gram. That's what goes on top and bottom. So we take grams and we cancel them out, and we do the math to get our answer. Pull up the calculator. Scooch it over a smidge. All right. So we have 0.0043 times 1 million. 1, 2, 3, 4, 5, 6. Times again 1,000. 1, 2, 3. Now, if it's at the top, if you're right here, you're multiplying these to each other. If it goes below, you divide it. So enter. And so the answer is, let me look at it again. 43 with 1, 2, 3, 4, 5 zeros. 43, 1, 2, 3, 4, 5. Now, this is milligrams. Now I'm going to show you how to check these last two particularly, using the gigaspace space, megaspace space thing. So I'm going to rewrite this number 670.7. I want to turn it into, here, let's write it over just a little bit more, make sure I have plenty of space. 670.7. I'm going to turn it from nanometers to meters. So if I go back up here and look at my little mnemonic device, and really you need to get used to writing it down, so maybe I can write it right here. It won't show up here. I'll write it right here. It goes gigaspace space, mega space space, King Henry drank Upkey, dark chocolate milk. Notice how I changed the capital letters to lowercase letters, because these are the tiny units where they're negative. And then space, space, the micro sign, micro, space, space, nano. Okay, get where you can write this out. Giga space, space, mega space, space, King Henry drank Upkey dark chocolate milk. Space, space, micro, space, space, nano. All right, we're going to go from nanometers. And so where's a nanometer? That's way over here. And we're going to go all the way to meters, which is the base unit right there. Okay, so I'm going to see how many places to move. I'm going to move my decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So here I go. 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left, and put decimal. And then I need to fill this in with zeros. And this would be the answer in meters. The only problem is it's not, you see how this is a -7? It's not in scientific notation, so I have to change it back to scientific notation. So to change it to scientific notation, I'm going to move the decimal so that it ends up being 6.707. When you do scientific notation, you have one number to the left of the decimal. So let's move it back. 1, 2, 3, 4, 5, 6, 7 spots. So times 10 to the -7. So see, I'm going from the left to the right. I'm going from the teeny. When I start with a number way less than 1, then the exponent is going to be a negative number. When the number is very much less than 1, it's going to be a negative number. So 10 to the -7 meters. So I just did it by shifting the decimals. Now, bridge notation is very important. It's not you're not always going to be able to shift decimals, but it's a way of checking. So let's try this with megameter one. We're going to go from 0.0043 megameters. And I'm going to turn it into milligrams, or megagrams rather, into milligrams. So write my mnemonic device. Giga space space, mega space space, King Henry drank Upkey dark chocolate milk, space space micro space space nano. All right, I am going from mega, which is this one, to milli, which is this one. So I'm going to move my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to the right. So I'm going to erase the unit so I can have an ability to do that. All right. So there. Oops. It was this. So see. So here's the decimal. Move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, and put a 0 in each spot. That's a decimal point. Okay, now I'm going to write it so it's a little bit more legible. So 4, 3, all these beginning zeros I'm not going to be needing now. I'm just going to need 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Look at that, 5 zeros there. Now this is also not in scientific notation. So I'm going to put it in scientific notation. And what I do is when I have scientific notation, I want one number to the left and the other numbers to the right. So here's the decimal. We're going to move it back to get in that spot. We're going to move it 1, 2, 3, 4, 5, 6 places. So 4.3 times 10 to the +6. And that unit is milligrams. Now, when your number, like this number, is large, your exponent is going to be positive. Exponent is positive. Over here, your number was super small because there was your decimal. A small number gives you a negative exponent right there. A large number gives you a positive exponent right there. Okay, now, I know that's a lot. I want you to now work on the seat practice. Let me go back to the Prezi for a moment. I wanted to talk to you before we get to seat practice. There's this major metric mistake that happened. I'm going to click this article for you. And it's 1999. What we had is this orbiter, this Mars orbiter, and it was a $125 million satellite. And there was a mistake. Whoops. Not right now, please. There was a mistake, and that mistake caused this to crash and burn, basically. And it's because the software calculated the force the thrusters needed to exert in pounds. We're doing ad blockers, sorry here. But the other parts of it were using metric units. And so because they did not correspond, the math didn't work, and they caused major problems. It cost millions of dollars in a mistake because they didn't have all the units in metric. Some of them were in pounds and some of them weren't. All right, let's move on to here. This is where we just got through talking. And I went through and converted all these using bridge notation, and also trying to show you a little bit of how to practice. Now, seat practice, use the bridge notation, and I want you to do these. Now, the thing is, I want you to try these, but I have this video right here where I work it all out for you. Okay?
Go through the part.
Now see, I'm going to go through all of this in this video. It will also begin chapter 3b. You don't have to do chapter 3b at the moment. We just have to get through chapter 3a. And so when you get done with that, it will be to 3b. It will be on the percent error and accuracy, which we'll cover a little bit later. Okay, I know this is a lot, so good luck with all of this.